Okay. So density curves, ladies, please. This chapter 2 is about these things called density curves. Oops. And the density curves that we'll be looking at for the most part will be like what's called a normal distribution, a t-distribution. But we'll look at some density curves that aren't these named distributions today. A density curve is a curve that's always on or above the x-axis. And a density curve has an area under the curve, always has area under the curve equal to 1. So if you've taken calculus, this is not something that, or are currently taking calculus, this shouldn't be something that's kind of hard to figure out. But if you haven't taken calculus, let me explain what I mean. So let's, ladies, will you stop? I've asked you several times to stop and you haven't stopped yet. Can you? I need a yes or a no. Thanks. All right. So, sorry, it's annoying today. I know the schedule is annoying. I know that taking a test is annoying when you have to keep talking to other people about it. So, I've got some, weird looking curve here. And it's a density curve. It's a density curve if it's always above the x-axis. So here's my x-axis here. And it has an area, if my curve, let's say, starts right here. I'll put my y-axis here and ends right here. It's a density curve if I can find all the area between the curve and down to the axis. If I look at all that area and add it all up, that area has to be 1. If it's more than 1, then it's not a density curve. Okay? So, this yellow area has to equal 1. And how can you figure out the area under this weird curve? Well, I'm not going to ask you to figure out the area under something where I wouldn't even give you an equation. But let's take a very simple density curve. And this I'm going to call a uniform distribution. And my curve is this line right here. Could you write the equation of that line that is a horizontal line that intersects the y-axis at 1? Y equals 1. Okay, good. Okay. And the area under this curve has to equal 1. So where am I going to have to stop here on the x-axis? At 1. Okay. So 1 times 1 equals 1. That area for that little rectangle, yes, is 1. Okay. So we'll answer just a few very simplistic questions about this. What percent of the area is between 0 and 0.5 on the x-axis? Okay. So that seems pretty straightforward, that that's 50% of its area. Let me just continue to draw this. So if I think about this little piece right over here, that has an area of 1 times 0.5. So that's 0.5. So what percent is that? That's 50%. Yeah. Okay. What percent of the area is between 0.2 and 0.75 on the x-axis? Let me think about what that looks like. Here's 1. Here's 0.5. Here's 0.2 here somewhere. Here's 0.75 here somewhere. Go straight across at y equals 1. What percent of the area is between these two lines? %? All right, so how are we figuring? My height is still 1 on this rectangle. What's my width? So this length right here is 0.75 minus 0.2. That seems pretty close to 0.55 to me. Okay, so my width is 0.55. So the area equals 0.55. The percentage is 55%. Okay. Besides percent of area, you can think of this as people who are in my whole population here in this yellow piece, or numbers that are in this whole yellow piece here, and so you might call them the percent of observations. So I'll reword this. What percent of observations are between 0.118 and 0.27? So is this 50% again? Okay. So when I say percent of observations, that's another way of saying what is the area under the curve when I mark off the horizontal axis to 0.118 and 0.127. So these are just different ways of asking the same question. Anybody do a little calculation for me yet? 50.2? 15.2. Okay, that sounded better. Oops. Okay. So that part should have been fairly simple. Now I'm going to ask you some statistical questions about this distribution. Same distribution. What's the median? The median is defined as the point on the horizontal axis where if I went up to the curve, I would have 1/2 of the area is to the left and 1/2 of the area is to the right. So the median is at 0.5. Where's Q1? 0.25. Q3? Okay. And if X is between 0 and 0.3, what percent of the observations lie on this interval? If I go from 0 to 0.3, what percent? So this is going to be. Oops, I didn't get my other mark in here. So if X is between 0 and 0.3, same density curve, what percent of the observations lie on this interval? 30% or 0.3. Okay. So should we make something a little bit trickier, a little more interesting for you to look at? Okay. So let's try new density curve. We'll keep it easy because we'll keep it going to the y-axis here. And I'm gonna say that the vertical side is the same length as the horizontal side, and it's a density curve. It's always above the x-axis, and we're going to go between 0 and I don't know yet, but since it's a density curve, the area under this line has got to be how much? 1. Okay, and if these two sides to this right triangle, the horizontal and vertical sides of the right triangle, are the same, what is this number here along the x-axis? What you think?
Square root by 2. Square root 2 by square root 2.
Oh, so square root of 2, square root of 2. Why, let's verify. That's obviously the same number. And how do you figure that that's the square root of 2 and the square root of 2?
So you half 1, which is 1/2, because that's height binary of a triangle, and then
Okay,
height
so area of a triangle is 1/2 base times height. Okay,
area has to equal 1.
so 1 has to be equal to 1/2 times square root of 2. We're just gonna solve. Sorry, I'm not gonna put the square root of 2 in there yet, am I? Come on. I guess we'll call this. Why don't we just call this base squared? Does that work for you? Okay.
You multiply this by both sides.
Okay. Nice. What's the equation of this line? Y-intercept is the square root of 2, and what's the slope? Slope is -1, so square root of 2 minus x. Okay. So they get tricky. What's the median? Now she started asking some really hard questions after she did something really simple. Got the median? Yes. So I need to figure out the point over here on the x-axis where half of my area is to the left and half of the area is to the right. All right, that's your problem to work on right now with your partner.